Welcome back, everyone. I hope our speakers booth provided a valued opportunity for more in-depth discussion on digitizing trade and supply chain finance. We hope these discussions amplify and encourage deployment of the innovative solutions being shared so we can safely and sustainably reopen our economies sooner. The COVID pandemic has triggered the most significant global recession in decades. In the 2009 Great Recession, an estimated 27 million people around the world lost their jobs. In 2020, 225 million jobs were lost. It's undeniable that governments will need to inject massive stimulus into our economies to support reopening and job creation. In the wake of the pandemic, there's been much talk around the world of an infrastructure-led recovery, because infrastructure spending is a tried and true economic stimulus strategy. Done well, it creates jobs in the short term and improves transportation, energy, and other public goods in the long term. However, governments today will be striking a balance. They need to strike a balance between the speed of getting this investment into the economy and meeting sustainability objectives. For the world to have a chance of reaching the targets set in the Paris Climate Agreement, the vast majority, if not all, of this infrastructure will need to be sustainable. Environmental and social sustainability will have to be built into the design, procurement, and contracting of these infrastructure projects, many of them in our global city regions. By 2050, more than 2/3 of the world's population are expected to live in urban areas, so cities will be at the forefront of these investments. This brings huge challenges and opportunities for investment in sustainable infrastructure. Our transport systems will need to be smarter, faster, and geared to mass transit and electric vehicles. Buildings need to be higher, greener, and more energy efficient. Investment and expertise will be needed in urban planning, water and waste management, construction practices, and sustainable energy provision. Technology and innovation have a critical role to play in the switch to the climate economy through sustainable infrastructure. Today, we're pleased to bring some of these innovations to you. Here to introduce our last panel of speakers is Director of Clean Tech at Toronto's Mars Discovery District, Tyler Hamilton. Mars is North America's largest urban innovation hub and has a specialized focus on the climate economy. Over to you, Tyler.
Thank you, Jan. I very much appreciate you inviting me here today, and welcome everyone to our panel on funding sustainable infrastructure projects. I'm looking forward to moderating this discussion and hearing from our panelists. As Jan mentioned, COVID-19 has had an enormous impact on economies around the world, with some predicting a 5% or more impact on global GDP over the next 5 years. And quite understandably, governments are looking at stimulus packages as a way to recharge economies in this post-COVID world. Again, as Jan mentioned, in a way that aligns with sustainability goals and climate commitments. Infrastructure spending has to be a big part of those packages to secure those immediate economic growth returns and enabling long-term sustainable growth. After all, if we're going to build back, we should take this opportunity to build back better. So with that, it's my pleasure to introduce our speakers. But before we do, I just want to remind everyone that the Q&A feature is open to the right of the screen, and if time permits, we'll be asking questions from the audience to our speakers. So please prepare any questions and feel free to add them to the chat. First up is Cosette Canileo, President and CEO of ABAC Infra Capital. Cosette has over 25 years of leadership experience in public-private partnerships, investment, corporate banking, and financial services industry. As head of the infrastructure arm of ABAC Group, she sets the overall direction for the company and its various business units. Welcome, Cosette.
Hi, thanks, Tyler. Good morning, everyone. I am Cosette Canilao, and I currently head the Aboitiz Infra Capital. Just a bit of a background of our company. Aboitiz Infracapital is the infrastructure unit of the Aboitiz Group of companies, which has investments in power, banking, food, real estate, and cement in Southeast Asia. The group believes in striking a balance between the interests of people, planet, and profit, and that is why it has made proactive investments in diverse sectors to ensure that our success in business continues to bring meaningful societal change. Today, I will be talking about one of our projects under one of our subsidiaries, how we're building Davao City's new sustainable water source. Next slide, please. My discussion will revolve around the project's background, its water energy nexus component, and our environmental protection and community building programs. Next, please. In Davao City, there are 11 main water supply systems, which serve about 70% of the city's 1.6 million population. It relies solely on groundwater sources from over 60 production wells scattered throughout the city. Water is pumped from these wells and is conveyed to the existing water systems. With this system, power interruption impact water production and distribution. Also, areas without good sources of groundwater do not have reliable service. The economic growth of Davao City has brought about rapid development and increase in population. In order to maintain this growth trajectory, rising water demand will have to be met in a more sustainable manner. Unfortunately, groundwater sources can no longer keep up with the demands of a fast-developing city, and there is already a danger of over-extraction. Over-extraction which can cause drying up of the wells, salt intrusion on the water table, and also land subsidence or the sinking of the land surface due to the loss of water underground. Next slide, please. Thankfully, Davao is blessed with the Tamugan River, the closest viable source of surface water. The city's water district partnered with Apo Agua Infrastructura, which is a joint venture company between Aboitiz Infracapital and JV Angeles Construction Corporation. The bulk water project will provide 300 million liters of treated water per day to over 1 million residents. This makes this project one of the largest bulk water supply projects in the Philippines. Next, please. The bulk water supply project consists of two main components. Part A, which is being undertaken by Apo Agua, involving the construction of the water intake facilities, hydroelectric power plant, water treatment facility, and treated water pipeline. Meanwhile, Part B is being undertaken by the Water District, which involves the construction of facilities for various offtake points, primarily transmission and distribution pipes and storage facilities. Once completed, this landmark public-private partnership will serve as a testament to Davao City's unprecedented growth and development. Apo Agua is fully committed to deliver this sustainable water supply to the residents of Davao for a period of 30 years. Next slide, please. The project will start at the Tamugan River, as I mentioned earlier, where an intake weir is being constructed. The water will then flow to a desander and into a surge tank. Then the collected water will then go to a treatment plant, which is a 6.8 hectares area located around 8 kilometers away from the city proper. Using the water energy nexus concept, the Tamugan River will also be the source of energy for the treatment plant, the first of its kind in Southeast Asia. The run-of-river hydroelectric power plant will generate over 2 megawatts of renewable energy and will power the water treatment process, which makes the facility self-sufficient. From the reservoir, the water will then go through the pipelines to the 8 offtake points for each of the water district service reservoir via a 57-kilometer pipeline system. Next slide, please. In addition to constructing the bulk water facilities, we are also supporting several environmental initiatives and community programs to ensure the sustainability and inclusive development of the stakeholders. First, we conducted a biodiversity study to ascertain the project's impact to the ecosystem and to develop mitigating and rehabilitation measures. We also conducted information campaigns to educate government stakeholders, local residents, and workers on the environmental features of the project and the state of the current diversity of the area. Second, to ensure the protection and conservation of Mount Tipulog Tamugan watershed, Apo Agua adopted 50 hectares of land in the watershed through DCWD's Adopt a Site project for the rehabilitation and protection of the site. Third, Apo Agua continuously tests and monitors the water quality in the river and coordinates with the water district to ensure early identification of contaminants and possible sources. We are also currently conducting a study which aims to develop actionable watershed protection initiatives that will be presented to the Watershed Management Council of the government. Next, please. In line with the Aboitiz Group's commitment to advancing business and communities, Apo Agua, either on its own or in collaboration of our Aboitiz businesses, other Aboitiz businesses, we've organized several community activities in our host barangays or villages. We conducted medical and continue to conduct medical and dental outreach programs, cacao agribusiness training for the local farmers, school maintenance and rehabilitation works, and a high school assistance and college scholarship programs for the residents and indigenous groups in the area. We also provide other indirect benefits such as job creation, development and improvement of roads, and electrification of neighboring areas. It is important to us that we take care of our host communities who are also our partners in the implementation of this project. Next slide, please. I think that's my last slide. So that concludes my presentation. Thank you for listening to me. Back to you, Tyler.
Thank you, Cassette. That was a great presentation, and thanks for telling us about that exciting project. Next up, it's my pleasure to introduce Jason Chen, Chairman and CEO of Acer Inc. Acer is a Taiwanese multinational hardware and electronics corporation specializing in advanced electronics technology. At its helm, Jason has played a pivotal role in driving Acer's corporate transformation and diversification into new business areas. Over to you, Jason.
Thank you, Tyler. As you say, Acer is a hardware PC company, but today, with our transformation, we are getting into diversification. So today, I'm happy to share with you some of our solutions and services. Today, what I'm going to talk about is focus on the water solutions, which is becoming problematic for the drastic climate change, becoming a crisis. So what I will do, the next page, is to talk two specific solutions. It's the Acer Smart Water Solutions on smart water meter and smart rainwater solutions for resilient cities. Next page, please. And next page. And let's start from next page, please. Let's start from smart water meter. From the left-hand side, left upper hand side, you can see the conventional water meter. People have to go check it out, the water usage and things like that from time to time. What we have done is to come out with an OCR and a connectivity solution. OCR means optical character recognition technology that will be able to just put on top of the conventional water meter and read the digits on how much and how many waters that people have used. And by doing so, we will be able to, number one, hopefully detect any water leakage real time. Secondly, we're using technologies and communication technology, including long range and low power wide area network for the concentrated area, and potentially for the longer area that wide distributed areas, we use the NB-IoT for 4G and 5G, so that we can save costs and also provide accuracy for how much water that each residence or companies have been using, or if any water leakages in the pipe, that we will be able to detect real time, hopefully faster, to save water and save labor. Next page, please. The next topic I would like to bring to your attention is resilient city, the preparation for climate changes. We all experience sometimes too much rain, too much water, sometimes we are in drought. And to solve this problem, I think it's time for every city, every country to start to look at how do we prepare for the resilient city, or on the other word, some people call it sponge city. Basic idea is to create, number one, a detention basin in public areas, and then for buildings, underneath the building to create drop foundation, so that we'll be able to keep waters and then use that as a buffer to keep water and let go the waters through sewer system and be able to create this resilient city. And so far, we have already done not just proof of concept, but implementation in one of the cities in Taiwan, Taoyuan. Next page, please. More specifically, this is coming to my last page, so bear with me. So coming to how do we do that specifically before, during, after the rain. Before we have foreseen a heavy rain or thunderstorm coming, we might want to empty the drop. And how do we do that? Look at the bottom of the graphic. We will put a water level sensor in the drop foundation and water level sensor in the sewer system. In between, there's a valve. So before, we will try to empty the drop foundation as much as possible. And during the rain, heavy rain, we will control, the control center will monitor the sensors and control the valves to let go and how to control the water. And after the water rain, will flow out of drop foundation as water supply, so that when too much water, we'll keep it. When not enough water, we already have reservation. And in between, it's very important to establish a smart rainwater control center with all the panels and the knobs that the administration will be able to have on hand to help to create this resilient city throughout the water supply, a smart water solution. That's pretty much what I have. Thank you very much, Tyler.
Thank you, Jason. That was very interesting. I long for a day when cities have all of these solutions there, so that we can prevent flooding and have a better way of tapping into that data that we need. That's so crucial to conserve the water that is also so increasingly scarce in some jurisdictions. So thank you for that presentation. Next, I'd like to welcome Robert Niven, the CEO and founder of CarbonCure Technologies, which I've had the pleasure of working with for over 13 years. A global leader in CO2 removal technologies for the concrete industry, CarbonCure is making concrete sustainability both profitable and easy for industry. Under Rob's direction, CarbonCure and its partners are achieving their mission to reduce 500 megatons of CO2 emissions annually. We're glad to have you, Rob. Feel free to start.
Thank you very much, Tyler. It's always great to see you again and to be here today. Unfortunately, not able to be present to see everyone and answer some questions. But I'd like to talk to you today about how infrastructure and new stimulus spending will impact GHG plans and what can be done to help to overcome some of these trade-offs. When thinking about today's presentation, I was recalling a recent article in the New York Times where it talked about a story where infrastructure bills have been passed in the US, and I think this is representative of just about every government represented here on the call today. They just passed a $1.9 trillion stimulus bill that we're all familiar with, and they expect an infrastructure bill to be passed sometime in September. The trade-off in all of this is if this is built according to traditional practices and materials, is this will actually erase the last decade of hard-fought greenhouse gas emission reductions. Of course, infrastructure spending is required, but governments need to insist upon companies to be able to be more creative and provide this infrastructure in a more sustainable manner. And that's really where CarbonCure aims to support, because concrete is by far the most abundant building material used in all infrastructure projects and would account for somewhere between 50 to 80% of the GHG emissions, or the embodied GHG emissions of projects. So it's the ideal place to start and really where our company is focused. Next slide, please. So let me tell you a bit about CarbonCure and some of the work that we're doing to make concrete both sustainable and provide it with higher quality at the same price. We're a company that's based in Halifax, Nova Scotia, Canada, so on the eastern seaboard. And today we're working with about 300 concrete plants over 3 continents, most of that actually scattered across the Asia-Pacific region. Our roots are in Canada. Most of our business is in the US, but have also expanded now into South America, Southeast Asia, East Asia, Australasia, and so on. We were recently voted the 2020 North American Clean Tech Company of the Year, and lucky you get to meet the 2021 Clean Tech Company of the Year next. So pretty excited to be on the same panel here with Steve. Some of our investors include Breakthrough Energy Ventures, Amazon, our Climate Pledge Fund, Microsoft, Shopify, Mitsubishi, and so on. You may have heard about CarbonCure and some of Bill Gates' recent work on, and his book and some of the 60-minute features around clean solutions for the new economy, where he talks about CarbonCure as being a solution for the built environment, specifically concrete. As Tyler said, our company's mission is really simple. Our goal is to reduce 500 million tons of CO2 annually by 2030. That directs all of our work in both growth and also innovation, and it's pretty exciting to have that clear-eyed focus to be able to direct our company as we move ahead. Next slide, please. How the company works is we, of course, don't make concrete. We provide retrofit technology that allows concrete producers to be able to consume CO2 just as any other feedstock, and making concrete that is made with actually a higher strength, which allows them to reduce their carbon footprint and while maintaining the same price point, so that the construction sector can continue to build with the product that they know and trust without having to compromise on quality or price. Next slide, please. Just understanding how the process and the technology is brought to market, and again, Steve, for your pleasure, we put in the CO2 source, in this case coming from one of your units. But CO2 can come from any source, whether it be direct air capture or today mostly post-industrial CO2. That CO2 is then transported to the concrete plant using existing supply chains, and where it's used as other feedstocks like aggregate or cement or some other chemicals and water. This then concrete is used just as it always is. In fact, the concrete producer and the concrete placer and everyone in the construction value chain is not aware that they're working with a much lower carbon concrete product, which is critical if we are really to be able to decarbonize the infrastructure and break this link that we've discussed at the top of the presentation. You can skip over the next slide and go straight to the next slide, please. So here's just an image of some of the CO2 that we're adding into the process, and what you can see is it's actually snow. So CO2 in its solid format, as it's added into concrete, is a solid product which is mixed in as concrete's being mixed, and a chemical reaction occurs. And that's really important because that actually permanently mineralizes the CO2. So what was once a harmful greenhouse gas can then be turned into a rock permanently, within concrete that allows it to provide better properties of both strength, sustainability, and cost. So that's really at the core of our technology. And this system is retrofitted in less than a day at any concrete plant around the world. So we've really been able to polish our scalability of this technology. And to make things better, we also don't charge any CapEx. So we'll provide this technology and service it and provide other services for free, or I should say the CapEx, or not everything's for free, for a recurring licensing fee, which is then paid for by the savings incurred by using this technology. Next slide, please. Looking a little closer at the concrete plant, or at concrete, what you can see is these little sugar cube looking particles. And this is really what we're forming, is this nano calcium carbonate, which is at the core of this chemical reaction, which is creating these competitive and sustainability advantages of making concrete with CO2. Next slide, please. To give you a sense of some of the impacts on the CO2 emissions, the impact is around, depending on metric or imperial, it's around 15 or even up to 25 kilograms per CO2 per cubic meter. With technologies that we are bringing out of the lab today, we can get that number up to about 100 kgs per cubic meter. So there's still lots of innovation to occur, but even today, these account for some pretty sizable impacts considering how much concrete's used. Next slide, please. As I said, we're adopted in about 300 plants, and I can already see that this image is already outdated with a number of new plants coming in the Asian region recently. And as you can see, also quite a few plants that are coming in as well in South America. Europe will be coming along soon within the next few months, and we see great opportunity because, of course, concrete's used ubiquitously. Lots of opportunity to consume a lot of CO2. Next slide, please. We've been used in millions of cubic yards of concrete in every conceivable kind of project that you can imagine, from heavy transportation infrastructure to buildings, to homes. And I was quite pleased just recently to hear that we're also going to be used in the world's first fusion reactor, which I think is really a testament to the quality and trust and concrete made with CO2. It's just a better product and a better way to make concrete. And we see every cubic meter of concrete that's being delivered as an opportunity to be able to benefit the climate rather than harm. So happy to answer any questions later on the panel and the speakers booth later on tonight. Back to you.
Thanks, Rob. You've managed to do the impossible, make concrete seem sexy. So good on you. Finally, rounding out our panel is Steve Oldham, CEO of Carbon Engineering. Steve brings more than 20 years of executive experience to Carbon Engineering's team, stemming from previous positions in technology, robotics, and aerospace. He has played a lead role with a number of Canada firsts in technology commercialization, including the first robot to perform brain surgery and the first commercial radar satellite. Over to you, Steve.
Thank you, Tyler, and good morning, good evening, good afternoon to everybody, and thanks for coming. I'm going to talk about the climate change problem at the highest level. Fundamentally, our challenge with climate change is very large volumes of CO2 in the atmosphere. And how are we going to address that in the scale that is required and the timeline that is required? Next slide, please. This chart is a great chart. It shows the cost of abating each form of CO2 emission across the planet. So along the x-axis across the bottom, you see the volumes of CO2 that we need to address to get back to net zero. On the y-axis is the cost to eliminate those CO2 emissions at source. So as Rob has described, there are many ways to eliminate CO2 and permanently sequester it. Some of them are cheaper than others. For example, on the right-hand side of that screen, next slide, please. On the right-hand side of the screen, you see very expensive forms of eliminating emissions. And I'll give you a very clear example, the aviation sector. So how do we decarbonize aviation? Are we going to replace every plane in the world with newly invented planes with huge batteries or with hydrogen? Replace the entire airport infrastructure? Are we going to ban flying? Are we going to make enough synthetic fuel to power every plane on the planet? It is very, very expensive to do that. An alternative solution, stop pressing sides, please. An alternative solution is that we don't stop those emissions at source. Instead, what you do is you eliminate the CO2 out of the atmosphere directly. So effectively, you clean up the atmosphere and the CO2 within it in the same way that we clean up our trash, our sewage, and all the other various types of disposable things we have on the planet. When you do this, and the chart here shows what happens if direct air capture, which is the process that carbon engineering has, is valued at $250 a ton. If you do that, you save an astonishing amount of money in addressing climate change. Broadly speaking, about $2 trillion a year you save by pulling CO2 out of the atmosphere rather than trying to stop CO2 emissions at source. And of course, this is a lot less disruptive. Changing every airplane in the world is very disruptive. Changing every vehicle on the planet is very disruptive. Instead, here is a way that is both less disruptive, faster, and also cheaper. Next slide, please. And then what happens if direct air capture is $100 a ton? At $100 a ton, we save almost the same amount again. The challenge we have in addressing emissions across the planet is the cost is in the trillions of dollars a year to stop every emission at source. Direct air capture, removing from the atmosphere, gives you an additional tool. Next slide, please. Keep going, please. That's the one. Thank you. So fundamentally, what carbon engineering does is two things, provides two tools in the fight against climate change. First thing, by pulling CO2 out of the air, you can put it back underground again. Our climate change problem has occurred because we took carbon out of the ground and put it straight into the atmosphere through the medium of fossil fuels. To fix the problem, we need to do the reverse. Take the carbon out of the atmosphere, put it straight back underground again. Or through permanent sequestration in other ways, like concrete, as Rob has described. The second thing carbon engineering can do, once you capture CO2 from the air, you can combine it with other products to make valuable resources. So for example, we combine our CO2 with hydrogen made out of renewable electricity, and that produces a synthetic fuel that is compatible with every vehicle on the planet without modification and has near zero carbon footprint. The picture in the bottom right-hand corner shows our fuel next to regular diesel. Note there's no black smoke. The carbon footprint of that fuel was removed in advance. So when you put it in your car or your truck and you drive, you put the CO2 back into the atmosphere again, we collect it and we make more fuel. Next slide, please. So is this real? Is this ability to pull CO2 out of the air, to reverse the amount of CO2 in the atmosphere, is that really, truly feasible? Yeah, certainly it is. The plant that you see on the picture here is under construction right now in the United States. Just one of these plants does the work of 40 million trees in permanently capturing CO2 out of the air. In this particular plant, we bury it back underground again. In other plants that we'll be building, we make that sustainable fuel that I mentioned. We will license our technology to any company or country that wants to build these plants. Why? Because the climate change problem is huge. We need to be fielding as many technologies as possible and as wide a scale as possible to address the impact of climate change. And remember, even once we get to net zero, we have put into the atmosphere 800 gigatons of CO2 over and above the level that allows us to have a sustainable planet. We have to remove 800 gigatons of CO2 to get back to a sustainable future. So having tools to remove CO2 is absolutely critical. Next slide, please. I want to finish by drawing an analogy. It's, to me, a very clear analogy. This is a discussion about infrastructure and infrastructure spending. So let's go back about 130 years. 130 years ago, people were dying in cities all around the world. People couldn't figure that out. Eventually, a guy called John Snow figured out that it was the water that was killing people. It was carrying typhoid and cholera. So what did we all do in response to that? We started to build water treatment technology. Today, we all expect to have clean water, safe water, wherever we go. A water treatment infrastructure is regarded as a fundamental responsibility of government for all our safety and health. Now in the 21st century, we have a problem with the air. The air and the CO2 within it is going to cause a massive change to our way of life unless we do something about it. So just as we needed a water treatment infrastructure, now we need an air treatment infrastructure. And countries that build direct air capture plants will have a way to eliminate any emission of any type anywhere in their country, but also any moment in time, and go back and fix yesterday's emissions as well as the emissions of tomorrow. And we should all remember that no amount of electric cars, renewable electricity, are going to deal with yesterday's emissions. And we have to deal with yesterday's emissions too. So that's direct air capture. At Carbon Engineering, we are very much at the forefront of this technology. Like Rob described, we were selected this year, privileged to be selected as the Clean Tech North American Company of the Year. We have some great investors alongside, for example, Mr. Gates. Bill Gates is a lead investor in us as well. So I encourage people, as they think about the infrastructure required for the 21st century, think about what we did for water and realize we now have to do the same for the air for the sake of our children and their children. Thank you.
Thank you, Steve. Great presentation, and congratulations on being named the North American Clean Tech Company of the Year. It's a great achievement. Now I'd like to welcome back all of our speakers for a group discussion. And a reminder to the audience, you can submit your questions through the Q&A feature to the right. Seeing a lot of questions come in already, which is great. But as more questions are coming in, I'm going to start off with my own question. So you're all bringing to market very different innovations that can help our economies reach their emissions and sustainability goals. How can we scale your solutions across the Asia-Pacific region, and what challenges or barriers stand in the way to that? And I'm gonna go to Cassette for this one.
Yeah, Tyler. You know, it will depend. First of all, there's a lot of variables to replicate this type of project to other Asian countries. First of all, the laws and regulation of that particular of the country, right? But then, can we scale it? Is it scalable? Is the project scalable? That depends also on how far the source is to where it's going to be distributed, the topography. And at the same time, well, I mentioned about the biggest challenge that we faced in implementing or executing this project is really the acquisition of right-of-way. And that it's, I think, a major problem across all ASEAN countries, right? So that's an area that will also, I think, be faced as a major challenge if we replicate it to other countries.
Great. Steve, if we kind of go over to you with the same question, obviously it's completely different technology, completely a different thing that you're tackling. I would imagine because it's so new, there are quite a few barriers you're trying to figure out right now. Can you address some of those?
Well, I think the good news for scaling direct air capture is that air is everywhere. So there really is no limitation as to where you put these plants. A lot of work is now being done on sequestering CO2, where are safe locations to put CO2. And the answer is there's a lot of locations all around the world, including many in Asia and the Asia-Pacific regions, here in Canada, in the United States, lots and lots of room to put CO2 underground. So I think what we're going to see in the 21st century is the development of a new industry and a new worldwide trading mechanism in carbon credits, just as we saw the same in the 20th century with the development of fossil fuels, and certain countries have the ability to be first in that market and scale because they happen to have fossil fuel underground. Now it's a different question. Do you have the ability to store CO2? If you do, you have the potential to build a massive new industry in your country. So for us, the technology is not the scaling challenge. It's more the realization from governments and policymakers that carbon removal is going to be essential. And the change in our economy here represents a huge opportunity for growth.
Rob, I look at your technology and I think it seems so simple. You're plugging into an existing process. I think that there wouldn't be any barriers. It's just an awareness thing. Like, just everybody needs to know that this solution exists. But obviously, that's a oversimplification. What barriers are you seeing in your business?
Thanks, Tyler. And a lot of hard work goes into making something look simple. So it starts in the lab and builds its way up. That
was a compliment, by the way, the simplification.
Yeah, thank you. Well, there's, I'd like to talk about one barrier and one opportunity. So first, you need to get rid of the barriers so that you can really scale these kinds of solutions like ours. And then from country to country, there may or may not be regulatory limitations on how concrete is made. So these were typically designed 50 years ago. They weren't contemplating things like climate change, using CO2 in concrete, or just innovation in general. So we need to make sure we have performance-based concrete standards that allow for CO2 addition. We have a lot of experience updating these regulations. It just takes a bit of time. Now let's talk about scale and sort of the positive side of things. And I'd like to point the audience's attention to some new legislation coming out of New York State called LECLA, LECCLA, which stands for the Low-Embodied Carbon Concrete Leadership Act. And this is essentially a procurement model where it provides a market signal for infrastructure developers on government projects to have a levelized bidding process where they take into account the CO2 reductions and whether innovations like CO2 utilization are being included in that bid as a way of selecting the concrete used for infrastructure projects. We've been involved in many different policies, and this is by far the most impactful way to be able to scale solutions, and it comes at no significant cost or none whatsoever, which is very important, but it just provides the market certainty for industry to move in that direction.
Great. Jason, I'm going to switch it up on you because we have a lot of questions coming in here, and there's one specifically addressed to you. Water preservation is an important problem, but we live in different places with different challenges. How do you think we can better share the information, like what you're collecting through your smart sensors, to help other countries out and to use best practices from one country for other countries?
Thank you, Tyler, and thank you for the question. To start with, we do have a turnkey solution, and the turnkey solution has been modularized with the design, either reader box or batteries, and they're all modularized. And we have ability to do customization, and the good news for that is Acer do have a global footprint. But when needed, our local office, our local resource will be able to work with the local administration and local government or system integrators who ever need to work with us. However, we are seeing some of the challenges, and can be incentive as well, opportunity as well. With that incentive from the administration, from the government to put on the bottom rate, especially for the buildings and new buildings to build on water draft, will be able to get higher volume rate. Then that will motivate people to take this extra step to preserve water and to help the resilience of the city. We have seen that in Taiwan and doing POC in multiple other countries and cities, and we are very excited about what can be done.
Great, thank you, Jason. Back to you, Cassette. We have another question from the audience. How can you scale up and down the projects of the nature that you're talking about to help service the many islands in the Philippines and also to other Asian Pacific countries with similar challenges?
Yeah, we're really thinking of using this project as a standard reference for other islands in here in the Philippines, right? But then again, it would depend again on the source of the water, where it is, the topography, how far it will be to the area where we will distribute the water. So and even the cities here in the Philippines, there are different laws and regulations governing local governments, right? So that's a challenge as well. How do we standardize this even across the Philippines, right? And how the challenge of standardizing this also across other countries, that will be another challenge as well.
Great. I'm hearing a lot of themes here: incentives, regulations, standards. Yeah. Steve, a question here. It says, with former President Trump quitting the Paris Agreement, did you notice more countries ignoring responsibilities for clean technologies? And how do you advocate for the cause on a global scale?
Wow, what a great question. I think the first thing to say is that different countries around the world are addressing climate change at different speeds, but also at different levels within their government. So while it was certainly true, I think we can all say that President Trump wasn't the most environmentally friendly president. The states in the United States and many cities in the United States brought in significant beneficial environmental legislation. And that movement, I think, has been significant. It's helped continue to drive the momentum. I think we're in a position where many countries and governments and companies have committed to get to net zero. Now people are beginning to say, what do I do about that? And they have curves that look very similar to that curve that I put up in my presentation. Some of my emissions are relatively easy to eliminate. Some of them are acceptable levels of expenditure. Some of them are a lot more. So what's going to happen is countries, governments, companies will focus on the cheaper, easier things to do first. That's just human nature. And we're going to have more and more of a problem. It's going to get harder and harder as we get closer to 2050 and as we continue to drive towards net zero. So for me, I have a very simple message. I can eliminate any of your emissions at a fixed price. And remember, 1 ± -1 is also 0. So when we're getting to net zero, stop the emissions you can. For those that you can't, give us a call. And hopefully a simple message like that helps people formulate their thinking about getting to net zero.
Yeah, it sounds very sensible. Rob, there's a question here that you partially answered already, but there's a second part to it. Is there any change required in regulations to modify the composition of concrete in order to use your technology? And the second question is, how do you source CO2 in foreign markets?
Yes, I believe I answered the first question already.
Yeah,
so
I believe you did, yeah.
Yeah, these are performance-based standards where permissions required. On the CO2 sourcing side, that's actually an even easier answer. Wherever you're drinking soda or a beer, there's already a CO2 supply nearby. There's a very established industrial gas industry that supplies CO2 to the food and beverage industry. This is the same CO2 used for concrete. And it's sourced from post-industrial sources like ammonia plants or ethanol plants. Now we're also exploring other sources of CO2 which have co-benefits in other industries that are highly emitting. And we're looking at sourcing that CO2 today as well to complement existing supplies.
So here's a question. Are you talking to Steve about using his CO2?
Yeah, but he won't sell me any. So I've been trying for years.
Well, hopefully someday.
Yeah.
I think we'll get that, Tyler.
Yeah.
We'll get that. Don't worry.
Okay. I have a question here for all of you. How do we balance the long-term economic benefits of infrastructure investment with the immediate needs to spend on healthcare and vaccination? So the crisis that we're facing now, as well as employee and business support. So in other words, how do we make the value of sustainability investments during a global recession much clearer? Who wants to take the first stab at this? How about Jason?
Yes, we believe sustainability is a long-term thing. It's now, it's never, regardless of recession or economy booming. We just have to do it. It's never too early, never too late. A good example would be RE100, renewable energy, 100% renewable energy usage is to be declared for commitment first, then business to convene, government to endorse, to encourage either government or business entity to declare first, set action plans, and then review the milestones. And once that's being motivated, in prevail, we think the difference will be met.
Okay, I said I was going to ask everybody, but we only have time for one more answer to this. So, Steve, you said you wanted to take a shot at this one.
Yeah, I'm going to have a go at this because it's kind of near and dear to my heart. You know, we're all witnessing the very significant impact of COVID. It has played havoc with our economy, many people's lives. It's taken many lives. Well, we have another virus coming, and it's called climate change. And the impact of that is going to be way higher. Wouldn't you wish that we'd had a vaccine for COVID in advance? Or we have a vaccine for climate change. We have the ability to fix it in advance. We just have to make the decision to do it. We may have to tighten the belts in a couple of other areas, but the benefits are going to be very significant. So I think the COVID example has unfortunately shown us that there are invisible things that can happen with a massive impact. And doing something about them in advance when you have the choice, in my view, is no choice at all. It's very obvious.
Good answer. And on that question about this being the pandemic being kind of a trial run for the determining our resilience and our response to the climate crisis, Rob, do you have any thoughts on that? I've seen many headlines over the past months talking about how if we can figure out how to respond to pandemics like this, we're going to be in much better shape when it comes to some of the crises we've already seen around the world related to climate change, which are expected to get much worse.
Yeah, I'm afraid I don't think I have a great answer to that. Maybe someone else might want to take a shot at that one, Tyler.
Sure. Like it comes down to the question of resilience. If this pandemic has been a good trial run for us to be able to test our ability to respond appropriately to climate challenges. Yeah.
So, and when I think about resiliency, and that's definitely something important as we consider infrastructure development, is we want to be able to build durably and for a changing environment, for sea level rise or many of the issues that Cassette had mentioned earlier. So I think that comes down to material selection and engineering design that needs to be at the forefront, as well as looking at the embodied CO2 emissions of materials we use to build with.
Great. Okay, thank you. It seems we have run out of time. So thank you to all our speakers for sharing your insights. And if you weren't able to get a question through, you can ask it yourself in the speakers booths that will follow, the links to which can be found below in the description and through the speakers booth feature in the main menu. But before those begin, I'd like to welcome back Chen.
Terrific discussion, everyone. Tyler, thank you so much for moderating. Cassette, Jason, Rob, Steve, a really timely and an incredibly powerful discussion. Unlike the other sessions we've had at the symposium, yes, regulations are a consideration in the deployment and scaling in some areas of the solutions you offer. But as it pertains to everything that you were talking about, awareness and amplification of your solutions seems to be the constraint that we need to work on solving. So I want to thank you for using this symposium to help share and to build awareness of the tremendous tools that you've developed to help us as we move forward. At this time, I'd like to offer some closing thoughts before the speakers' booths begin. First, a thank you to Global Affairs Canada for partnering with Apex Business Advisory Council on this event. They, along with our speakers, moderators, and our amazing support team, have made the symposium possible. And second, I'd like to leave you with a challenge. Collectively, APAC economies are home to around 3 billion people. Over the past 3 days, we've convened leading innovators offering solutions to key economic challenges created by COVID and beyond. The common thread through these discussions was that technology is very much ready now. Our constraint is the enabling conditions and the awareness to deploy these powerful solutions. And this is where we're turning to you. As an audience representing private corporations and public entities from around APEC, we have the collective power to create the conditions to deploy these solutions. Solutions that will help our markets reopen sooner and sustainably, and help our economies recover faster. So please consider the topics and speakers that align to the problems you're trying to address. Reach out and continue the discussions that we started at this symposium, because those 3 billion people that make up APEC are counting us to do so. Thank you again for participating in this symposium. And with that, we'll move into our final speakers booth. And please, everyone, keep the conversation going. Thank you and take care.